Example 5, boundary value problem. Alright, let's see if I can go through this really quickly. So, remember, these are in terms of x. Why is it in green? Okay. Remember, these are in terms of x. Didn't mean to do that. Those are in terms of x. Let's start with, let's work our way up. Well, I can tell you right now, this becomes this. I'm just gonna kind of go through this really fast just to show where the different case happens. This is the same thing as the last one. Let's look at this one. This is literally the same thing as the pi one, but now we just have an L here, so this might even be the same thing almost. Alright, let's just go through it really quick. I think it is like the exact same example, just with an L instead of a pi. I guess that does change it. That does change it. This would be C1 plus, actually minus. Yeah, just like the last three. Same thing happened. Okay, C2e to the bam plus C2. Next one. Right? That's an L. Hope you can read my handwriting. These are mu's, by the way. If you see some weird squiggly things, those are mu's. Kind of looks like a backwards Y. It should look a little bit more like that. But I'm kind of getting sloppy there. Okay. Equals 0. Let's take out this. Oh yeah, this one's nice because yeah, this one's very nice because this is gonna go to 0, and we're left with well, so mu is gonna be 0 from this one and from this one because you can see that this is obviously mu equals 0, but for this one, in order for this to be equal to 0, mu has to be equal to 0 because then that's 1 minus 1 equals 0. So mu is 0. So if mu is 0, then we get oh, it's one of these ones again. We're gonna have two eigenvectors, two eigenfunctions. I mean, sorry. Y is equal to 2, C2. So we're gonna mark this one down. Okay. And we're gonna get that for every one of them. That Y is constant. So let's go ahead and when eigenvalue is 0. Now this one we should get the same thing. You know, this is just going to be repeated. You know, I can tell this is literally the same thing as the last like 3, 4, 5 examples. However many it's been. Prime of 0, I think. Yes. C2 is 0. Look at that. Y is a constant. And then we take another derivative, so then that just goes to 0. It's pi, right? No, L. That's just 0, so that doesn't tell us anything. So look at that. That confirms it again. Y is constant. Okay. Yeah, let me write non-trivial. non-trivial. Can't forget my smiley face. Can I get this one done in under 8 minutes? Less than 0. Greater than 0. Okay. Which one would that be? Minus. So then we have repeated, complex. That's 1. Cosine mu x plus c2 sine mu x. That's a mu. Man, that looks bad. Okay. Y prime of 0. This term becomes sine, goes to 0. This becomes cosine. C2 is 0. Wow, this is like the same thing we had for the last 3. 2, I mean. So that's that. And then this could be a eigenfunction, I would say. Let's find out. This is L, right? Yep. Prime? Yep. Yeah, it definitely could be a eigenfunction, I would say so. It is, yeah, it is. And we can see the mu on the outside here confirms the constant y. I'll show you why in a minute here. Just like the 2 problems, example 3 was just like this one. This might even be the same thing, pretty much, just with an L instead of a pi here. Equals 0. So you can see here mu is equal to 0, and so let's find this one out. This works if, what cosine has to be a pi over 2, right? So then it's n minus 1/2 times pi. So then mu. Oh, not this again. Okay, so let me write it like this. Same exact thing, right? I think that's right. Let me make sure. This is 18. Number 18. Oh no, I'm incorrect here. What am I doing wrong? Should that be... Oh, it should be... Wait. I'm seeing that it should be... Oh, yes. I made a mistake. I'd take the derivative, it should be sine. So then this is just n pi, right? Yeah, that would make that a lot different. Whoops. Okay. Yeah, okay, so let's make our little chart here now. As you can see, when lambda sub naught is equal to 0, y sub naught is equal to a constant. We'll just call it c sub naught. This 0 just shows it as being, because this is what happens at 0. And then after 0, we have lambda sub n occurring, which is, this is squared, so let me just write it like this. You could just square every term there, but like n squared, pi squared, l squared, you could write it like that too. The eigenfunction, we're looking at this one here. Cn cosine n pi over l times x. Yes, okay. I forgot to write this down on the other side. And before I finish, let me make sure that's right. Yes, that's exactly what I have in my notes. Okay. There's the answer. This is just like example 3, I think. Just like example 3. Alright, so we still have one more example left. Let me take a look. Oh yeah, that one's pretty similar to another one we did as well. I'm not too sure why I did these last two, to be honest. But let's go ahead and do one more example, because why not? See you in the next one.